Alrighty, let's see. Hard one day, so let's see if I can actually do it. Find the number of subsequences with equal GCD, greatest common denominator, I think. You're given an integer array nums. Your task is to find the number of pairs of non-empty subsequences, sequence 1, sequence 2 of nums that satisfy the following conditions. The subsequences sequence 1 and sequence 2 are disjoint. Mean no index of nums is common between them. Okay. The GCD of the elements, greatest common divisor. Divisor, not denominator. Yep. Of the elements of sequence 1 is equal to the greatest common divisor of the elements of sequence 2. Return the total number of such pairs. Modulo 10 to the 9 plus 7. All right, so before I forget, set up like that. Okay, so task is find the greatest, your task is find the number of pairs of non-empty subsequences. They're disjoint. Greatest common denominator of subsequence 1 is equal to greatest common divisor is equal to the greatest common divisor of sequence 2 subsequences. Right? Subsequences are not just kind of random elements or some sub-elements. I guess I wonder why it's subsequences rather than subsets. Because I don't think a subsequence of, if you have an element in a subsequence, and you're trying to find the greatest common divisor of it, I don't think it makes a difference between that and a subset. Okay, anyways, the subsequence pairs which have the greatest common divisor of their elements equal to 1 are 1 by itself, 2, 3, 1 by itself, 2, 3, 4, 1 by itself, 3, 4, 1 by 1 and 2, 3 and 4, 1 and 4, 2, 3, 4, 2, 3 and 1, 2, 3 and 1, 4. One and 3, 4. So it can be mirrored, I guess, right? 1, 2, 3, 4, 1, 2, 3, 4. Or 3, 4, 2, 1, 2, 1, 2, 3, 4. So it's gonna be an even number, obviously. Okay. Yeah, I'm not sure why they say this is subsequence rather than subsets. Okay, I guess the only thing here would be that the greatest common divisor would be 1. Can't be possibly the greatest common divisor would be 2 because you'd have to have 2 and like 4, 6 or something like that. 2 and 4, the greatest common divisor of those would be 2 and 4. Yeah, okay. 10, 10, 20, 30. So 20 and 30, greatest common divisor of that would be 10. Greatest common divisor of 10 by itself is 10. So it's 10 and 2, 20, 30, or 20, 30 and 10. And this one. Huh. Okay. How to tackle this? It's not very big. And considering that this is subsequences, which has a lot of possibilities, that makes sense. Nums value themselves aren't very big either. Okay, what can I do here? I think given the fact that the num values themselves are 1 to 200, I could possibly regenerate the prime factorization of them, or pre-generate the prime factors of them. That can be too long. Regenerating prime factors would allow me to quickly identify the greatest common divisor. I mean, it would be pretty long, I guess. 1, 1, 2, 1, 2. I guess everything includes 1. So 1, 2, 2. Everything includes itself. So I can ignore those 1 and the number itself. So like 4 would be 2. 6 would be 2, 3. I can maybe even shrink it if I ignore 2 as a factor for evens. I think tackling these, example 2 and example 3, should probably do a lot of the work or handle a lot of the cases. So if I find the prime factors of each value in nums, find the prime factors of each value in nums, greatest common divisor. Greatest common divisor. So let's look at example 2. So the prime factors of 10 is 2, 5. I guess it doesn't necessarily have to be prime factors, right? It has to be all factors, maybe ignoring itself in 1. 20 is 2, 5, 10. Missing a 4. 30 is 2, 3, 5, 10, 15. 3, whoops, missing a 6. Greatest common divisor. So obviously, if it's just a single value, the greatest common divisor itself. Greatest common divisor is always a increasing number, no, decreasing number as you increase the number of elements. As you increase the number of elements, right? Because you can never really add another element to the subsequence and get a bigger common divisor. I wonder, so if I made some sort of mapping of divisors and their the values that are within the array that divides by them. So 15 is just 30, right? 30 is 30, obviously. 6 is just 30. 5 is 20, 30. I mean, I guess I could technically add in this other one as well. What does that give me? What does that give me exactly? So if I group 20 and 30, wait, what happens? Yeah, if I group 20 and 30, that gives me 10. But if I group 10 and 30, that also gives me 10. But 20 by itself gives me 20 by itself gives me 20. Or 10 and 20 and 30 by itself gives me 30. Yeah, it's just not going to work. This line of thought, not going to work. Number subsequences. 10, 20, 30. 10, 20, remaining 30. Greatest common divisor. Trying to total number of pairs. Probably think about this wrong, to be honest. Probably thinking about, ooh, what am I thinking about? Greatest common divisor. Order doesn't really matter. Like nums could be in random order, nums could be in sorted order. Count is going to be the same. What if I should try to tackle this problem first? Like if there's just a bunch of duplicates. I guess I can, okay. Do the maybe simpler case. If there's just like, let's say there's 5 ones. Just as an experiment to calculate if I'm calculating it correctly. So how many ways to formulate 2 subsequences in this case? The subsequence could have 1 element, 1 element versus 4 elements, 1 element versus 3 elements, 1 element versus 2 elements, 1 element versus 1 element. What is the mathematical principle here? So if that first element is the first one, let's just keep it simple here. Ignore the fact that this is 1, 6, 3s. So greatest common divisor can be just 3. The first 3. How many subsequences are there, right? There's 1, all 5, 2 4s, 3 3s, 2 2s, and no, 1 5, 2 4s, 3 3s, 4 2s, 1 1, or 5 1s. What is the quick way of calculating that? Probably 2 to some power. If the subsequences hold 5 1, 5 1s, and then there's how many ways of grouping the 4? There's 5 elements. There's 5 plus 4 plus 3 plus 2 plus 1 ways of making a subsequence from that. If there's 4 elements, there's 4 plus 3 plus 2 plus 1. So I think it's something like 10. So 1 plus something up to 4 is going to be 10 ways of doing that. Subsequence, 1 element subsequence plus either 4, 3, 2, or 1 as the other subsequence. There's 10 ways of doing that. And then a 2 element subsequence, which is going to be actually 1 and up to 4. I guess there should be 5 times 10, no? Oh boy, 5 times 10 is not it. Choose 1 as my 1 subsequence. There's 5 ways of choosing that 1. And then there's the other subsequence. There's 1 way of getting 4, 2 ways of getting 3, 3 ways of getting 2, 4 ways of getting 1. Seems like it'd be 5 times 10. That doesn't seem right. Oh, that is right. This is I was thinking that the answer should be 50, but the answer is this is for 4 element. This is 5 elements. So yeah, it's 5 times 10. This is a 1 element plus up to 4. 1 element subsequence plus an other subsequences up to 4 size. Then the 2. So the 2 is you choose 2, which there's 4 ways. No, there's not 4 ways of choosing 2. Oh, there's not. I'm counting this wrong. I'm counting this pretty wrong. All right, let's go. Let's go something simpler. Okay, let's go something even simpler. Am I doing this? This is 1 way, right? Choose 1, choose 1. No, there's 2 ways here. Choose 1, choose 2, choose 2, choose 1. Okay. Right. Okay. Say this is example A. So this should be 1 times 2. If it's 1 and 1, size 1 on each. It's 1 times, choose 1. There's 3 ways of choosing the first one and 2 ways of choosing the second one. No, identical. Not 3 times 2. I mean, it's 3 times 2, and then you divide by the factor of n. What is the count for when there's mirroring? Oh boy. Counting principles. 3 feels like it should be 1. Feels like there should be 3 ways total of picking 1 and 1. 1 length subsequence, 1 length subsequence. And then there should be another 3 ways of picking 1 length subsequence and 2 length subsequence. So that's 3 plus 3 is 6. I'm guessing it should be 12. Pretty sure. Okay. Okay, so let's go ahead and do. I guess I should just try to, even if I know the answer is 50. How did they get this answer? So if it's 1 and 1, 1 and 1, it'd be just 4 choose 2, no? 4 choose 2. One of them is the first one, that's the second. 4 choose 2 would be 6. 4 times 3 divided by 2. 3 choose 2 is here. Is that right? Choose 2. Yeah, and this one's like 3 choose 1, kind of. It's like 1 and 1. Length subsequences. This is like 1 and 2. This is 1 and 1. 4 choose 2. I think that's right. Okay. 1 and 2. Or choose 2. Is that the same thing as 4 times 4 choose 1, 3 choose 1? Order doesn't matter, so divide by 2. I think that's before choose 1, 3 choose 2. Then order doesn't matter. So divide by 2. Four choose 1 is 4. 3 choose 3. 3 choose 2 is 3. One. One. Pick the other 2 is 3 ways. 1. Pick the other 2 is 3 ways. I think this is just 12. This is 1 and 2. I guess then it could be 1 and 3, right? 4 choose 1, 3 choose 3. 4 choose 1, 3 choose 1. Why is this 6? 4 choose 1, 3 choose 1. Because you can't differentiate them. The first choice and the second choice. Yeah, I guess maybe, huh? This is going to be 4 times 1. And then 2 and 2 would be 4 choose 2 times 2 choose 2. 4 choose 2 is 6. 2 choose 2 is 1. Should this be 3 though? 2, 1, 2, 2, 1, 1, 3, 2, 4, 1, 4, 2, 3. I think this should be 6 divided by 2. I think. Because they're kind of identical, like the 1 and 1. 4 choose 3. This is technically 4 choose 1, 3 choose 1. So it's 12 divided by 2, which is 6. And then I think that's all the cases: 3 and 1, 2 and 1, 1 and 1. So 6 plus 12. 12 plus 3 is 15. 6 plus 4 is 10. 25 times 2 is 50. I'm getting the answer, but I don't feel great about my understanding of the math. Like when I should be really dividing by 2 versus not. I mean, intuitively, it's like because of the mirroring of the choices, like choosing 1 and choosing 1, they're kind of identical. Choosing 2 and choosing 2, they're kind of identical. So because they're identical, you can't tell the difference between choosing the first and second. So it's like dividing by 2 is the number of actual possibilities, distinct possibilities. But choosing 1 and choosing 2 versus choosing 1 and choosing 3, those are strictly a difference. So therefore you can't divide by 2 or whatever. But this is just not generalizable even to the most simplistic of cases where all the values are the same. What is the pattern here? 1 and 1, 1 and 2, 1 and 3, 2 and 2. One and one, 1 and 2, 1 and 3, 2 and 2. So, I mean, all these things could be done with 5. So 5 choose 1, 4 choose 1, 5 choose 1, 4 choose 2, 5 choose 1, 3, 4 choose 3, 5 choose 2, 3 choose 2. All these things can be done with a higher number of n. Yeah. So this was like 3 choose 1 times 2 choose 1 divided by 2. And this was 3 choose 1, 2 choose 2. And this was like 1 choose 1, or 2 choose 1, 1 choose 1 divided by 2. Oh my God. Oh. Um. Do, 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 do. Hard. Barn. Glad. 54% got it. Good for them. Well, I feel like this is probably some form of I always go to the dynamic programming excuse or idea since it's so small. And there is a lot of similarities between the different test cases, the different man, how can I solve this with dynamic programming? 1, 1, 1, 1. So up to a certain, so I think, so I'm gonna say I think this is dynamic programming. And if I can formulate a way of counting that would work. So if up to a certain index I had the number of subsequences that used, if up to a certain index I had the number of subsequences that had a certain greatest common divisor, right? So up to index 1. Up to index 1, I'm going to have, let's say, I have something where it's index, and then it's tuples or some sort of data structure that keeps track of GCD value and the count of the ways of getting that GCD value, count of subsequences. Okay, so for instance, on example 3, up to index 1, there's like a GCD value of 1, and there's like one subsequence, which is like just the 0. And because 1 itself is 1, that means the greatest common divisor of that is 1. So this is like 1 times 1, which is 1. So there's like a total of 1. So like this 1 and this 1 is kind of subsequence 1 and subsequence 2. But now I update the count of the greatest common of the number of subsequences that have GCD 1, and now it could be this one, this one. So the previous count plus the one for the self plus some multiplication, right? Or some number of ways of incorporating this into the subsequences prior. So the number of subsequences that have 1, so like up to index 2, the number of subsequences that the greatest common divisor of 1 should in theory be 3. A singleton, or both. So I'm not sure how you get 3 here, but it is 3. In which this 1 is the answer. This is 1 total. So here, up to this sequence, this is a 1. So it could be this 1 as subsequence like 2, or subsequence 1, and any other ones as the other subsequence. So any of the other 3, so it's like 1 times 3. So 3, and then that adds to the total, so it's 4 total. All right, up to index 3, the greatest common divisor of 1. So how many ways here? Should be 1, 2, 3, 4, 5, 6, and 7. There should be 7 ways of getting that. I'm not sure how you calculate that without manually counting it, but it should be 7, 3 1s, 3 2s, and 1 3. Length subsequences. So it's 1 times 7. So it's 7. Brings the total to 11. That's not correct, is it? That is not correct. Okay, this is I see, I see. This is just one and another number. One and another number. 6, 12, 4. 6 plus 12 plus 4 is 20, 22, which is 11 times 2. Do, 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 do. Uh, 1 greatest common divisor value, the count number of subsequences. Count of the number of subsequences. 7. So if this value is 1, there's 7 previous ones. Oh man. How would I do pairing like subsequences of length 2 versus subsequence of length 2? I'm also not sure why I double twice. Like I double this to 22 and then I double again to like 44 out of the 50. 1 and 1. 2 and 2. So if the last element is greatest common divisor is 1, and there's 7 previous subsequences. So I can combine this one with one of the other 7 subsequences. That doesn't really work because the 7 subsequences could be like one of those would be all 3. Combining it with that all 3 makes a. Maybe I actually need to have the breakdown. The number of subsequences, the greatest common divisor, the length of the subsequence, and then the number of subsequences with that length. So that I know that there's like 3 1s, there's 3 2s, and then there's 1 3. But I can't keep track of that much information for every greatest common divisor. Seems like too much. Oh my god, it's just the most simplest of cases. I mean, I guess the count of subsequences could just be a list, right? It could be 1, and then there's like 2 1, 2 2 that are 1 length, 1 that's 2 length, and there's like 3 that are 1 length, 3 that are 2 length, and 1 that is 3 length. Why is there 3 that's 2 length? 2 that are 1 length plus 1 more that's 1 length. There's only one that's 2 length. There's only one that's 2 length. There's 2 that's 1 length, 1 that's 2 length. Two that are one lane. One that's two lane. So there's two that's one length. There's an extra one at the current spot. So there's three that's one length. There's only one here, then there should be like maybe what is going on here? Okay, up to index one, there's up to index one, there's one that's one length. One subsequence is one length. Up to index two, there is two one length subsequence there that have greatest common divisor of one. There's one two length subsequence that has greatest common divisor of one. So moving to this index, there's three that have greatest common divisor of one. Then there should be three that have greatest common divisor of one that's subsequence length two. Why? If I can choose, there was two here. Oh, okay. There was two here, which is this one. And then this one combined with either the ones. So it's one plus the two gives me the three, I think. And then the other one is the three length. Um, can I generalize this to, okay, if there was a fourth index, basically if there was a fifth one, then this should be four. And then this should be how many two length ones? How many two length ones? So it should be any of these three plus any of these three. So I think this should be six. And then the number three length one should be, so six is three plus three. Three length ones should be this one plus any of these three. So it should be four. And then all four should be just one. So I think it's like that. So it looks like Pascal's triangle without the starting one. Yeah. Or so this should be 1 times 15, is that? Yeah, it's 1 less than power of 2, huh? So that gives me a total of 26. Yeah, I got no. This ain't going anywhere. This ain't going anywhere. Oh my gosh. So hard.